Welcome to this interview. I'm David Kassmeyer from the United States, here with Ray Tomes from the Cycles Research Institute, and we're here to talk on location at Ray's home here in Auckland, New Zealand. The subject of this interview is
an overview of cycles.
It is an overview of cycles. Thank you, Ray. Ray, you've worked on cycles research like nobody else for decades, but there are a lot of people who are new to study of cycles, to cycles research. So I'd like to ask you a very fundamental question, Ray. What are cycles?
Yeah. Cycles can occur in almost anything. They mean a repetition after a more or less regular amount of time. So there are cycles in our daily life. Days, months, years. Cycle of light and darkness is the day. The cycle of the season is the year. Cycle of the phases of the moon should have been a month, except we've messed with that. But there's a lot more cycles than that. We look at the tide coming in and out a couple of times a day.
Yes.
The waves in the sea coming in are cycles.
Yes.
And when we look at cycles, we find, although they may be more or less regular, they're not necessarily perfectly regular. Like the waves coming in, they aren't perfectly regular, but quite clearly there's a cycle. There is a wave, there's not a wave, there is a wave, there's not a wave, and so on.
Yes.
And the waves will have a different cycle in different places. So when we go to the surf beaches, there's these great big waves that come at a wider interval.
Yeah.
And just down the bottom of our section here, in the harbour, there's little waves that come in more often.
Yes.
But they're both cycles, and there may be some relationships between those two. So I'm going to look at this list here for this because I might miss some.
Okay.
But this is these are some of the things that have been cycles found in geology, biology, meteorology, astronomy, sociology, dendrochronology, which is the tree rings.
Yes.
Health, economics, climate, physics, something I can't read, wars and history. So there's cycles in all these things. Indeed, we might say, physicists probably wouldn't express it this way, but we might say physics is the study of cycles in some parts of the natural world, the non-living stuff.
Yes.
Because ultimately, what we find is sound waves, are cycles.
Yes.
Light, very high frequency cycles.
Yes.
All atomic structures, they have constant state of vibration. So this thing of vibration is throughout everything.
Yeah.
And they've been studied in many different things. And astronomy is one of the earliest things where cycles were investigated. And these go back to ancient times beyond recorded history.
They do.
But we do have records that in ancient India, they'd studied a lot of cycles in astronomy and other things. Later on, the Britons were very early in the piece as well, and the Chinese. The Briton built Stonehenge. By that stage, they understood the motion of the moon and the sun.
Yes.
And they could predict eclipses, which is not an easy job.
Not at all.
And they did this by the motion of little stones they moved around the circles to keep track of those things, because that's complicated. We can think, okay, what's a year? A year? The Earth going around the sun,
Yes.
and it's got a tilt on its axis, so one season gets a hotter time when the other one gets a cooler time, and then the other way around over here, and then we get the in-between seasons.
Yes.
And that's okay, but the Earth's got an elliptical orbit, and that gradually wanders in space, and the pole doesn't always point the same way. It does this precession of the equinox. That's another cycle, 25,000 and something years.
Yes.
Then the moon's going around.
Yes.
Okay, it's not quite in the same plane. It's roughly in the plane of the Earth's equator, but it oscillates about that.
Yes.
So there's one cycle of it going around, another cycle of it wobbling its orbit, another cycle of its ellipse moving in that space, and these things lead to a bunch of cycles. There's monthly ones, and there's ones that take some years, and there's ones that take much longer. So all of these things lead to quite complicated situations. So, for example, it's been suggested, and it's generally accepted, that the cycle of ice ages is attributable to these aspects of the motion of the Earth's orbit. So we've got the ellipse,
Yes.
we've got the tilt of the Earth's axis relative to that,
Yes.
and the precession of the equinoxes causes the seasons to occur at either the closer part of the sun or the further part, and makes them more extreme. So we get a factor from that. The tilt of the Earth's axis is not constant. It goes a little more, a little less, a little more, a little less, in a cycle of about 41,000 years.
Yes.
And the Earth's ellipse is not the ellipse of the Earth's orbit, where it goes closer to the sun and further.
Yeah.
It's not constant either. It gets more circular and more elliptical, more circular, more elliptical. And it does that on two cycles, one of about 100,000 years and one about 400,000 years. And when the
and does that ellipse turn as
yes,
well?
Yes, it turns in space as well.
Yes.
And so all of these things come together to make quite a complicated pattern. And studies in geology can show, and in things like the layers of ice that are put down in the Antarctic and in Greenland and other places.
Yeah.
What they can drill down, and they can go back hundreds of thousands of years and see how the climate has changed by measuring isotopes in these things, which will tell them. Yeah, they can, and so they've gone back as much as 800,000 years, but there's quite a few of them that go back over 100,000 years with these. And with those, they can see that these cycles, the Milankovitch cycles, 23,000, 41,000, 400,000, that they cause cycles of ice ages, going in and out of ice ages. And we're in a period now which is called a glacial, which means in the longer term cycles of geology, it's an ice age period. But we're currently in an interglacial. We popped out of the ice age for a moment being 10 or 15,000 years out of the 100,000, and then we're going to dive back in again. Although some people suggested human actions might change that. I'm sceptical about that. It's conceivable, but we're at that point there where we could be going back into an ice age in the not too distant future. It's worth mentioning that the same universities that now say we're headed for catastrophic heat effects from human activity, just 40 years ago were predicting we're about to enter a new ice age. This prediction of this business is very, very difficult.
Yes.
Even though you've got cycles and you know that something's going on, you can't always predict, but that's one of the things that cycles can be used for. We can be fairly sure tomorrow morning the sun will rise at approximately the right time. We wake up and we'll have some daylight. So we set our alarm clocks for that time and get ready a bit before. So
everything moves in cycles, right? But it's the things that we're familiar with, part of our everyday lives that affect us, control us, influence us, things that we work with. We're all familiar with the years, the changes of the seasons. We're all familiar with the tides and everything like that. And we're talking about weather changes. We all know about the age of glaciers and what we're in right now. But how often do we talk about these things? You call them by their names and analyze them. Do we always think of them as cycles?
Yes.
Cycles are not part of our everyday lexicon, yet things that are cycles by another name are.
That's right. Yeah, for sure. Yes. And people that get into any given one area often find cycles there. So I mentioned geology already and climatology. There's very clear cycles in those, ranging from 600 million years right on down.
Yes.
There's cycles in business cycles. There's cycles in the economy. There's long ones and short ones.
Yes.
There's a cycle of 50 odd years, which is called the
Kondratiev wave.
After a Russian guy that first mentioned it. He wasn't that first mentioned, but he's the first one that made it commonly known. There were other ones that mentioned it before.
He did.
And so that one we can see there's major depressions on that cycle and so on, and then periods of more prosperity in between.
Yes.
And what I've found, I believe the cause of that might be related to human demographics, because when the going gets very tough, people make less babies.
Yes.
Making less babies means that a generation later, the economy is not strained as much as they enter the workforce.
You know, Ray, it's easy for us to understand when we think about fish population in a pond versus the food supply, because it happens on a much shorter time. But when we were inside the fishbowl ourselves, we don't have an outside point of view, except through the analysis of history.
Yeah, when you get all the data and look back long periods. And then what happens is people, when the times get good, people make more babies, and a generation later, they have tougher times because they can't make the jobs fast enough for them, and they can't make the houses fast enough for them. So those things happen, and then there are much shorter economic cycles as well. There's like 3 and 4 year ones and so on, and 7 years and 9 year ones, and different things. And it's all, what can we say is a possible cause of cycles? I think a good example I like is you get a person on a swing, and you pull them out one way and let them go.
Yeah.
Now, what are the two things that are there? There's a displacement from the original position, which causes their weight to pull them back.
Yes.
Because they're connected there, they can't fall straight down, so they get pulled back this way.
Yes.
And so the displacement leads to a returning force. And when they come out this side, the displacement that way causes returning force.
Yes.
And that's generally, that in physics is called simple harmonic motion. And in some sense, if we slightly vary the terms, it doesn't have to be a gravitational force. There's some force, whenever there's a displacement, there's some force that makes it want to return to the original state. And the same, that's true in economic cycles. It's got to be true in geological cycles. There's got to be something, we don't necessarily know what causes those, but there's something that's causing it to go back to the original conditions. It doesn't wander off to infinity. And in the case of the rotation of the Earth, it's more simple. It's just going around in circles.
Yes.
But many other things. So what did I say? What did I have on that list again there? So there's cycles and wars. Now everyone's heard of one cycle that people mostly have heard of as a cycle, as the sunspot cycle.
Yes.
And there's 11-year sunspot cycle. We get more and less over an 11-year period, and that repeats. Not regular. It's not a perfectly regular cycle, but it's moderately predictable. And it's because there's multiple components to it, or if we can call it modulation. So the cycle gets a little bit stronger for a number of cycles, and it gets a little bit weaker again and stronger. We've just experienced a weaker cycle for the first time in a while, and those weaker cycles occur about every 100 years, and an even more weaker one every 200 years, which is what we've just had. We're now at the point where the cycles will start to get stronger again, those 11-year sunspot cycles. But it can vary. It can be 10 years, 11 years, 12 years, sometimes even a bit outside that.
Yeah.
So the same, when we studied wars, it turned out a couple of people, Geological was one in Russia. He got the history going back 2,500 years, and he analysed when all the wars, how many battles, he did it by battles and that, and how many occurred and how severe they were, and he put this whole thing in history, and when he made a graph of it, he discovered, there's an 11-year cycle in it.
Good heavens.
But when he did further analysis, he found, there was also a 22-year cycle. Now, the Sun actually has a 22-year cycle because its north and south pole are this way.
Yes.
After 11 years, it goes and flips over, and then we get the next cycle, and then it flips back to the next one. So there's a 22-year cycle in it as well. But he also found a 6-year cycle in it, and a cycle of about 54 years, which was old Kondratiev cycle again.
Yes.
Which just shows up in the economy. So here we've got a connection between wars going on and economic conditions, some relationship there, which causes which, or does something cause them both? And then even longer ones, you found a 142-year cycle.
Cycles in everything. So the cycles of one thing can very often influence something else.
They can.
And it may look like that something else is moving by its own volition, but really it's being influenced by an outside source.
Now I'm going to come back to that in a moment, because I want to first mention the foundation for the study of cycles, and Edward Dewey, who was the leading force to the foundation, the formation of that in 1941.
Yes. And
he had been studying cycles in the economy for some years before that, and his first job was to try and work out why the Depression happened. And his answer was, he interviewed 100 economists, and they gave him 100 different answers. And 99 of them he totally dismissed because they all contradicted each other, and none of them could predict it before. Yes. And one of them said to him, "Edward, we really don't know." That was the one that was right. But he got some further advice from someone, which was, don't try to work out why, work out what happens. So he began to work out what happens with these cycles and see them. He didn't try to explain why. And through doing that, he came to understanding, and he realised that there were actually a bunch of different cycles happening in the economy. And if you ran them from the historically forwards, you could actually predict that 1929 crash.
Wow.
Interestingly enough, not knowing about Dewey, I was doing the same thing in 1986, and I worked out there was going to be a crash in 1987.
And there was.
And there was. I was a month out, but I wasn't expecting to be any more accurate than that. And later on,
more than 500
and this
points.
happened in the 80s. A few years after that, I found out about the Foundation for the Study of Cycles and visited there, and I found Dewey's cycles from the 1960s. He gave the phase of each cycle and the length of it, and I ran them forward from the 60s, and it also predicted the 1987 share crash.
Oh my goodness.
Right?
Yes.
So he had them measured pretty well. And it's quite amazing because for most of the time he was studying cycles, they didn't have computers. Or they weren't, you couldn't afford them to do it. And so he had these teams of ladies writing numbers out in rows adding them all up and did them all, and he worked out a number of techniques to do that, to measure the cycles, and he had a number of techniques to highlight them and show them. So, and having mentioned that, these 4 books, which I think we can see on the camera there, these are called the Classic Cycles Classic Library Collection.
Yes.
And they represent, in effect, the summary of many of the best works of the Cycles Foundation through to the time they were produced, which I think was about the 1980s or 1970s, somewhere about there.
Yes.
I've got a couple more here on cycles from Cosmic Influences and Cycles in Humans and Nature. That'll be produced by members of the Cycles Foundation. So there's a wealth of studies. He lists the topics there, and there are many hundreds, if not thousands, of different time series that have been analysed for cycles, plotted on graphs, and see, oh, there's a cycle. And maybe when you look at it a different way, maybe when you look at the long-term trend, there's a big cycle and superimpose on a small one, and so on, and often many cycles that can be found if you analyse the data properly. So that's all going on.
Yes.
It's like if we look at the temperature, we'd find there's a daily rhythm, getting colder at night and warmer in the early afternoon, but we'd also find there's an annual cycle.
Yes.
And then we might find there's some longer cycle where generally we get cooler seasons and warmer seasons and so on as well, over different periods.
So we have cycles within cycles within cycles.
Absolutely, yeah. And so that's a general gist of what cycles are. The Cycles Foundation studied these many hundreds or thousands of areas and catalogued literally thousands of different cycles they found in different things and what length they were. Now, some of those studies are a little crude. Just somebody somewhere who maybe wasn't a cycles researcher, who was in some particular field, got a number of years data and thought, oh, there's an 8-year cycle in this. They might have had 2 or 3 year cycle. You can't measure it very accurately. If you get more data, you can say, yes, this is an 8-year cycle, it keeps going. And then if you get a lot more data and you know how to do the maths of it, and the maths of this is well developed, it's well accepted and well studied, you can then find that you might find it's a 7.92 year cycle or something like that. You can measure it more accurately if you've got more data. And so those are all catalogued. And then we began to do some other things with it. Mm-hmm. He decided to make a histogram, and he put here the length of the cycle, and he put a little mark on there for each one he found. And it turned out in some places there were a huge number of cycles found, in other places there was next to nothing. So he looked at those different ones, and he made a little chart. Mm-hmm. And he started at 17.75 years, because that was one of the common ones. And then he halved it, 8.88 and 4.44 years. These were common cycles also. And he also took a third of it, 5.92 years. And he made this table by dividing by 2 and 3, and also multiplying by 2 and 3. He got some the longer cycles, 71 years and 35.5, 71 and 142 years, which have turned up in different things. And so he made this chart, and he said, this has got many of the common cycles in. They are related to each other by simple proportions of 2 and 3. Now, for anyone who knows the foundations of music, those Pythagoras worked out ratios of 2 and 3 as the main thing in music. So, and that little diagram, half of that diagram he had, is actually Pythagoras's lambda. But he doesn't mention that anywhere that I can see. I can't help but think he knew that. But then he didn't quite know how to stop this thing, because he found some other cycles that didn't fit it. So he found a 40-month cycle in the stock market, which also was in interest rates and things from way back, was known in the 1800s even. And that one, it didn't fit into the pattern. And then there were some other longer ones that didn't fit the pattern either.
How did he reckon these anomalies?
He didn't mention it. So, like, for example, there's a 9.6 year cycle in the Canadian lynx population. It goes up by a factor of 10 and down by a factor of 10 over a 9.6 year cycle, and they've several hundred years data. It's a pretty regular cycle, very spectacular cycle, so that people that were trying to trap these for their fur might as well give up some years, in other years there was an abundance. And then people found there was a snowshoe rabbit that these lynx ate that had the same cycle in it, and so they thought it was a predator-prey relationship. But that doesn't really stand up, because it turns out that there's salmon in the Atlantic have the same cycle, and some sort of 10 caterpillars have it, and there's something else and something else. There's at least 10 things are on the same cycle. And that was one of the reasons why they had a conference at Matamak in the 1920s in Canada.
Yes.
And a bunch of Americans went there, and it was they were mainly university professors and such, or some people that worked with wildlife and things as well. And they studied this, and they had a number of these different cycles they'd found in different things, but they'd found multiple occurrences of the one thing. And it was when Dewey found out about this conference, within weeks he had contacted the man that organised it, and he'd organised to get them together. And very shortly after that, they agreed to form the Foundation for the Study of Cycles. They'd had some sort of intention to do that earlier, but it had never been realised, and he was the driving force. And they brought together people from these scientists who were studying nature and things, and they brought together business people who were also interested in the things there were cycles in business as well.
And so they were attracted by the fact that it was synchronized as well, because when you talked about the animal populations going up and down, not only were there so many of them following the cycle, but there was a cycle synchrony. They're all going up and down at the same time. And what they found is that this correlated the same synchronies with economic changes in the United States.
Yes, that's right. Yeah. And so that was he had a number of rules there. There are certain cycle periods that are very common, lots of cycles with the same period. The next one was, they had synchronies between them. Yes. And the next one was that they had these proportions between their periods that were, exactly twice or three times as long or whatever.
Wow.
And so those things, there was a picture there. It was mysterious. No one could work out why it was happening, but it was a clear picture, and this stuff was clearly going on. Now, these days, I try to put stuff about this in Wikipedia. All the facts and the studies on this, large numbers have been put in peer-reviewed journals, and they're real established facts. I haven't talked about anything at the moment that's a little bit questionable. And so there are cycles in the fashion of cycles. Cycles coming out of fashion, and we've been through a period where cycles is not popular. And you start to explain things in terms of cycles, and the people that are what we might call establishment in the universities and other ones, and they reject the stuff from Wikipedia as being wrong, merely because they weren't taught it in university.
Yes.
And so we've got to change that and have people knowing about these things, because often people are doing things wrong because they haven't got this perception of those. So one of our main objectives in these interview series and in the things we're going to do following on from it is going to be to let people know more about the cycles that are happening in every different field, because they are in every field. There's nothing Dewey said, there's nothing that's been studied that hasn't got cycles in it.
Quite true.
And he's quite right. And the other thing he said, which I really like, is the study of any field of human knowledge that is done without the knowledge of cycles is like the study of disease without the knowledge of germs. In other words, it would be very sad, because you wouldn't be knowing what you're doing. You'd be working in the dark. And that's actually what's happening, because these cycles they're there. He describes it, and this is where we depart a little bit from what people are going to find acceptable in the establishment. Is that he described that there's a mysterious force. Now, we don't have to get new agey or anything, but something is happening that causes the regularity of the cycles. He found that when a cycle didn't happen as it was expected to for a little while, some major eruption of something else overrode that. Afterwards, it returned to the original pattern, the original synchrony again.
So an outside force causes an aberration, and it might spike up or spike down as a result of that. But once the aberration passes, the cycle resumes again, and with the same phase that it was in before the aberration.
So something mysterious. Mysterious doesn't mean not able to be understood. It just means we don't know what it is at the moment.
Right.
But something is causing these things to go. In my opinion, there is a force, and in my opinion, each particular area has its own natural resonant frequency. Like if we make different length swings, they will swing backs and forwards with a different period. Make a longer one, it's slower. Make a shorter one, so it's like that. and it's a relationship between the displacement and the restoring force determines what is the frequency of that cycle. So
and the confluence of that, if I may say, can sometimes be confusing. Because if you were someone sitting on the top of that swing set, and that swing set has many swings on it, each one of a different length,
it would be wobbling.
You're going to feel it moving.
Yes.
But you're not necessarily going to differentiate that there's a swing of this length and that length and that length.
Sure.
So sometimes, we're all moving to the music, but we don't always understand that the orchestra that plays that music to which we move might have woodwinds, brass, timpani, and strings.
Yeah.
But when we can identify those individuated parts and then realize how they work together in the system, then we can understand the confluence, and that's why they remain hidden.
Yeah.
But then, when we do identify that, we find that each one of the elements contributing to this song is really something simple in itself.
Yeah.
And then it's the combination that makes it complex, and that's why it's been invisible to us sometimes.
Yeah, that's right, in many cases, And it was the same with when the ancients were studying the motion of the planets, because the Earth was moving around the Sun, and the planets were moving around the Sun, and so they did it was quite clear that, like, Jupiter went around about 12 years, but it did these little funny bits in the sky at times, and particularly the inner planets did these retrogrades and stuff, and that due to the motion of the Earth, and and that would have been possible if the Earth was moving in a circular orbit and all the others were, but it was complicated by the ellipses, which meant non-uniform motion. So it wasn't until a genius like Kepler could put it all together and say, these are the rules. The planets move in ellipses around the Sun.
He gave us the three planetary laws of motion, which are fundamentals. They hold true today. And we also didn't understand a lot of what we were seeing, or why a planet would start reversing its direction. It was because of parallax, the apparent motion of one body in motion while viewed from another body in motion, which is in our case Earth. And sometimes we have a parallax and don't understand our own point of view right in our own internal affairs.
Yeah, and when we study these cycles and other things, there are things that look a bit like the epicycles and so on that were there before Kepler, but they're a bit like elliptical motions and stuff. There's something, we can see that there's something like that going on in them as well. So it's a fascinating area to study and try and work those out. And it doesn't matter what your interests are, you can find them. In sociology, there's movements of things in fashion. There's cycles of fashion. There's cycles of everything.
Everything.
And it's something we can work on, and we can the cycles of war. We can come back to that one at some point, but we've been through a period where at the 11-year cycle there have been more wars. If you go and list the dates of the recent sunspot maxima, 1956, 1960. I think, 1979, 1990, 2001, and you can rattle off the list of wars that started at those times. Some relating to Russia, some relating to America, and so those, and we're at the point where the some of those longer cycles, the 54 and the 142-year cycle, have been at a relative lull and may start to increase again. So there's a lesson in there which we need to get to the politicians. It's something happening there.
Well, there was an American politician, John F. Kennedy, who was elected president in 1960, and he was asked something about the conflict sometimes between poets and politicians. And he replied to that interviewer. He said, if more poets were interested in politics and more politicians read poetry, we'd have a better organization. And so it is with cycles too. Because if you want to understand whatever you're doing, in order to understand anything about it, you really need to know the cycles that are influencing you, and that gets you a step closer to understanding everything.
And poetry is related to music and song, and those things are full of cycles, and fascinating cycles in their own right, much more on the surface. There's the notes with the frequencies and the harmonies, and often multi-part harmonies and that, but there's also a lot more there in the rhythm of the pieces as well. Absolutely. And you get that all builds up to longer cycles.